So we talk about algorithms, they're not electronic devices. Okay. We're not talking about CPUs, we're not talking about the architecture. We will talk about algorithms and how a little difference in how you write your algorithm would make a huge difference in how it is executed by your computer. So uh, today I want to focus on just two aspects of it. The running time and the memory that we use when we run an algorithm. And I feel like the easiest way to do it is just to show you how much you spend if you take one line of your code and you put it somewhere, and you take the same line and put it somewhere else, and you feel like it's the same job that the code is doing. And you would be right. Like we will see with the example that I will use today that it's the same job that the code is doing. In the end, you have the same result, but it's not doing it the same way. Meaning, it's not using the results the same way. It's not spending the same amount of time to complete. So keep that in mind. That's what we will talk about today. And for today's example, I will use C++ vectors. They are so easy to manipulate, and I think it's a good starting point if you want to think about memories, right? Because those can be sometimes pretty huge. Like if you have a very big data set, your vectors can be, I don't know, 3,000 elements, sometime even 30,000. I have been processing some vectors where I have like 300,000 elements. So you have to be careful when you have that size, to handle. And again, this is another point that we will discuss today. When you do something, when you do a small job, when you have a small program running on a small data set, it looks like it doesn't really make a huge difference if you take one line and put it somewhere, and you take the same line and put it somewhere else, as long as the output is the same. When you use like a small data set, or when you're processing a small database, it looks like it doesn't really matter. In a way, it doesn't, because from the human point of view, the way we scale time and resource, maybe it doesn't, right? But then you increase the size of your database, then you realize there is a huge difference. So that's what we will discuss today. So let's get right into it. Um, Again, I said I will be using C++ vectors, right? So this is what we will do. I need to include the vector. I can type to or what? I probably also need to include. Am I going to? I don't know if I'm going to do anything very specific. I don't know, but I maybe I want to use the big. I can normally use QQ debug to display some outputs if I want, but maybe I want to use something else in the other stream. I don't know, and I will use the. Oh my god, I can't really type to the what happening. So namespace std. Okay. So we can actually start right here, and we can discuss a few things. In terms of memory, everything that I'm creating in this function in the main is in the main as long as I'm running the main function. If this is something like in the end this is going to be a module, if I run this module, everything that I create inside here will be there as long as this function is being executed. Which means if I create another function and I create something in that function, everything that is inside is used as long as that function is being executed. And this is a very basic principle, which is by default, all variables that you create within a function are local to the function. And if you create something within a function and you use it somewhere within a loop, it is not local to the loop unless you create that variable within the loop. So if I create a loop, if I open a loop and I create something inside, when the loop is done, that thing is also gone. Okay. But if I create something before the loop and I use it within the loop, after the loop, that thing is still alive. So I need, if I want to get rid of it, I need to find a way to create it so that at some point I will get rid of it because I decided to. So keep that in mind. Which means we will do a few things. Oh, another thing is if I create something out, like right now, this is the main, and this is the main CPP file. So if I create a vector here, let me just go ahead and create one. A double x1. I can have access to this anywhere on this file. If I create it somewhere here, I don't know with the new, I think with the new standards, you can have access to it. So if I create it somewhere out, but below this main, I should be able to have access to it in the main. I would have to double check that because, you know, those standards are evolving every year. So yeah, I think the new standards in C++, you should be able to. I will have to double check that though. But yeah, if you create X1 here, you can have access to it anywhere below, right? Could be in the main, could be in another function, which means this much information is saved in the memory that your computer will allow to this execution for the time this program is being executed. So unless you close the program, this is how much you will take in your memory. Keep that in mind as well. So now if I create something inside the main, something different, and of course you can use the same name, but it's if you want to go crazy and play around with your laptop or your computer, right? If I do this, you see, and the reason is this variable is local, this variable is global. So now there's going to be a problem. And I don't think the problem is going to be that you want to use this because it's a global variable, but you want to use it locally. I believe what will happen is this is what the main will use, not this, because this one is local to the main. So I think the main will prioritize this instead of this one. So this one you will use. So if you don't have anything here, but you have something here, you will be using nothing in a way. It's a bit funny to say, but yeah, in a way, that's what it means. So you can, let me go ahead and change this name. I don't like it. I don't like to play around with my computer. You can do this, okay? And everywhere below this line, I can use x2. I know I'm saying things that people know already, right? But I think it's important to say those things in the beginning so that at some point when we are talking about actually what is really happening, it doesn't look confusing anymore. So over here, I have I'm declaring my variable x2, and I can use it anywhere below this line 11, right? So, you remember we said we would talk about running time and memory, like the balance between how fast you can go and how much memory you're using. So to do it, we will imagine, for example, that this vector is, I don't know, 100,000 points or elements in it. And we will imagine a loop in which we do something on that vector, and we will imagine a loop where we create this vector within the loop, we do something with that vector, and then we we get back the result of doing that thing. could be anything, could be ranking, could be sorting, could be multiplication. So you'll see. I have an idea, but there's just so much example that we can use. So uh, let me go ahead and do the for loop. 0. This is just to create the number of 1000. Hopefully I can count 1,000. Just trying to fill that vector now. I'm old school. I think there are new functions in C++, the new standards that you can actually use to, maybe you want to initialize this with a specific function. There might be like the zeros in MATLAB or the rand that will give you a vector. There must be, they probably have something like that now. I just don't know. So it doesn't matter. So x2, I'll push something into it. Let's just push I, so to speak. So now we have 100,000 elements in that vector. And yeah, I'm trying to think about something like a good example now. I can just sum them all up and return the sum. That will be good. Okay, I think it's a simple example. Okay, let's do that. So we need to do something, which is I will take x2 and sum all those elements in x2 and return the sum. So probably need a double to save that sum in it. And over here, the sum is just x2. It's been a long day. I can't even type my keyboard. That's the sum. So now you can probably return it. I mean, display, not return, but you can probably display the output. The sum is yeah. And if you run, oh, I need to include QD. Oh, okay, I will probably have a yeah. That's my bad. I need to get QDebug in here. And I need the hashtag. So now it should be okay. And so that's the sum. Super fast. I mean, very super fast. I mean, probably I will need. Do I need X? Gosh, I don't think so. Let's just yeah. Let's keep it that way. So the code that you see here is because I'm closing it myself. So when I run my script, this is open and it's still waiting. It seems like not. It seems like it is like this. The program is still running because it's supposed to be somewhere that is interactive. So the way you do it in Qt, when you use the QCore application, it's basically as if you're creating a program, but with like a common prompt kind of command line kind of program instead of GUI interface. And so the idea is still the same. It's supposed to be something where you can type stuff and get some result if you want, but like, batch command instead of just using the interface. So that's why it's still on. So if I close, then you will have that code, but it doesn't mean that my code has a problem. As you can see, there's no problem there. Okay, so we can stop here and then I can explain a few things. I'm using this vector and I create the vector before I can go in the loop and compute the sum, right? Let's suppose that to create this vector, I need 5 seconds or 1 second. Let's see, one is good. Let's suppose my computer will need 1 second to create this. So let's suppose this part of my code normally takes 1 second to get implemented. So right now the way and let's suppose the sum will take like 5 seconds. So let's suppose this part of my code, it's taking 5 seconds to be implemented. So right now the way it works, it means that the entire script from that point to this point, it's taking 6 seconds, which is not true, but I mean, we just saw how fast it goes. But like, I'm just supposing, right? I'm just putting numbers so that we can understand what I'm trying to explain. So if I take this one, so if I take this part and I bring it in here, what do you think would happen? First of all, if I have to do it, then I will need, let's say this operation is something that I have to do 100 times, right? If I take this and I bring it inside here and I put this loop like from 0 to 99, then I'm repeating this 100 times. So it takes 100 seconds to build this. And within the loop, I do this, which is 5 seconds. So 5 seconds, 100 times, 500 seconds. So in total, 600 seconds instead of 6 seconds, right? But now the problem is, if I do it within the loop, there's something different. Right now, when I run my script, because I have this dude out of the loop over here, if I run the script, the memory that this variable is using is still taken, right? There's no empty memory at this address because it's like x2 has a few numbers in it, and those are still being used at this moment unless I close the application, right? But if I take x2 and I bring in the loop, the moment we are here, so the moment we're out of the loop, there's no memory being used by x2 because x2 is local to the loop. And so the thing is, if I take it and I bring it inside, my code will take longer to implement the task, but it's using less memory because in the end, this is how much you free up when you're done with your loop. But if I keep it outside and I do this 100 times, I'm using less memory because I create this one only. I'm taking less time because I create this one only once and I repeat this 100 times, which is 1 second and 500 seconds. So that will be 501 instead of 600 seconds. See? So if you think about it now for bigger problems, like when you do, for example, simulations, it's even worse. For simulations that I do, I have a vector of vectors, which is like a two-dimensional variable. And I have another vector, one-dimensional variable that I use, and I use a linear solver to solve ax equals b, and I after solving, I do some array multiplications. And so, I mean, those different steps that like the different steps that I'm calling now, those are taking a little bit of time, but also a huge uh part of your memory. And so when you're designing your algorithm, you want to make sure in the end, even if you want to use it, if you want to be able to run it faster, as fast as you can, you want to make sure you're not going to run out of memory at some point. And so sometimes it's good to know how to play around with the structure of your algorithm just to make sure that you can actually come out with something that is optimal, you know, in terms of how fast you can run it and in terms of how much memory you're using when you run it. And so the easiest way is to look at these things. How many vectors or how many variables do you save for a long time in your script? And do you think there is a way to make it so that you don't save them for a long time? Do you think you can just create them the moment you want them and get rid of them as soon as you don't want them? One way of doing it is with pointers. This is why I love pointers. So if you create a pointer, even if I do it here and I use it, if I feel like I don't need it anymore, I can just erase everything. Another reason why I love C++ actually, because with vectors, x2 now has something in it. If over here I just say, okay, I'm done with x2, just clear everything, then I don't have to worry about x2 anymore. So like I'm good now. The memory, like the size of information that I'm saving here is gone. So now we're good. I still have a little bit of memory used because of just creating this, but it's fine, right? It's not that's not a big deal. It would be a problem if I still have like 100,000 elements in it because those are doubles. You should be able to do it with other language, although I don't know how easy it will be. But this is one of the reasons why using pointers are kind of very, very, very useful. So if you create a pointer here, when you're done, you can just free the pointer and move to the next lines. If you want, instead of using pointers, you can just identify the part of your script where you want something and create that thing over there and just remove it. So if I feel like I can create a function to do all this job, then it's perfect. I will make a second function right here. Like I can do something and call it, you know, make some, I mean, okay, make a sum. And I can ask I can take as an input a pointer to this vector and the size of that vector, right? And in this, I will use, actually, I can even do this. If this is something that I'm reading from a file, I don't even need input. So if this is something I'm reading from a file, I can just, you know, have an empty function like this. If I know exactly where the file is, I can just read. But if I don't know where the file is and I have to provide the path, then I can probably, let me just include string here before. Then I can probably use a string to get the file path, and then I will use it here in the read. So now you will read, which means all of this will be in this function. And so that way, when I run this function, this is how much memory I will be using and this is how much time I will take. But as soon as I'm done with it, everything is gone. So everything that is within that this function is gone, and I only have the value that, you know, the sum that will return in the end. So this is one way of looking at this type of a situation. So to make it simple, you should be very careful when you have very big vectors or very big arrays in your script, in your program or your code, in such a way you want to make sure you call them just when you need them. And if it's possible, if you feel like you were not using them again somewhere else, empty the space so that you don't get issues with your memory. And make sure for running time, make sure you go around your loops, especially loops because those are structures where you spend a lot of time in your code. So make sure you're not doing something repeatedly when you can actually just do it once and use it, right? So if there is a vector, this is something very you will see this very often when you run statistical algorithms. If I want to do kriging, the huge big K kernel, I can just compute it once. I don't need to do it 100 times unless I'm using locally varying variogram or unless I'm using locally changing neighborhoods. If I'm not using those, then it means I will be using the same neighborhoods for all my prediction, and you will not have to compute k x amount of time. But when you have to do, for example, locally changing neighborhoods, most of the time k is small, so you're good. Even if it's going to be something that you will compute within a loop, the size of k most of the time at that moment is small, so you're fine. You don't have to worry about that. But if you are in the situation where the size of k is big, then again, maybe you can think about using a function, right? Because you don't want to save k for a long time in your script. So that's what you want to think about. Now, this right here, we're talking about this right here, and it's just like a single thread. So this is just running on one CPU, for example. If I use distributed memory architectures, this is even worse, right? Because distributed memory architectures means I will have a copy of this dude p times. So p being the number of processes I'm using. So if I'm running my script on, let's say, 10 processes, I will have 10 x2. So now the size of x2 is 10 times in my computer. So if this dude is 1 GB, I have to prepare 10 GB just to save this dude. And how about everything else in my code? And this is where you start having problems with your memory. So that's why I want to talk about this, because it's good to understand when you have those problems where it might be coming from. So whenever you have memory issues when you run your script, especially if you're doing HPC, think about this. What is the size of my variables? You know, how much am I taking from the results to save them, and how long am I saving them, and do I need them to be saved that long, or is there a way to get rid of some of them when I'm running my code? Actually, another good point would be using files, right? I have one specific vector that I'm using for this amount of time, then I'm not using it for this amount of time, but then I need it back. So what do? I can create the vector, save it into a binary file, use it when I want, get rid of it when I'm done, and then call back the binary file when I feel like I need that vector back. Just another idea. Instead of saving it for forever in your framework. So yeah, keep that in mind, and yeah, this is how you can actually start troubleshooting your code or your algorithms when you run through memory issues. I hope this will be helpful, and I'll be coming back with updates.